guys, today we have a new topic in which also is my research topic, which is known as Middle Eocene Climatic Optimum MECO event, which is what is the global overview in the Pakistan focus. So MECO is the event in which they occurred 40 million years ago. Almost 4 to 6 degrees centigrade the temperature rise throughout the world. The stage is Lutetian to early Bartonian, and the O18 oxygen isotope is decreasing. So it's mean that O16 is increasing. So it's mean the warming is increasing 4 to 6 degrees centigrade from the normal temperature. There is, you can see the different event of the different area, like the Jurassic early Cretaceous, PETM, the PT extension, the KT boundary, and here this is my research area, MECO, Middle Eocene Climatic Optimum. This is the stage where this climatic optimum is occur, and this is the oxygen isotope, in which you can see it's shifting, decreasing. So it's mean that O16 is increasing, O18 is decreasing, which directly interpret that there is some event is occur, and there is another event you can see some is increasing, some are decreasing. So depend upon the oxygen 18, so we interpret that it will be global cooling or global warming. So what about the carbon isotope excursion? Because we discussed the oxygen isotopes, now carbon isotopes. So there is no significant carbon isotope excursion, because globally the CO2 input is gradually, not directly input, and in different site, in different position, the carbon excursion is sometime maximum, sometime minimum, but it's not like a globally too much carbon dioxide is input, so there is no significant negative carbon 13 isotopic excursion. While in contrast to PTM, which is the almost go to -10, so because the carbon isotope excursion is too much, so that's why the value is too much negative. So it's mean that C12, the carbon come from the organic carbon, is too much around the PTM, because the carbon 13 isotope is too much decreased, but here it's only 1.5, so it's mean minimum excursion. In Pakistan, the carbon isotope excursion along the MECO, there is one paper published in which it also shows the very positive, too much positive. It means that very limited organic carbon is input during this event. MECO was firstly found in oceanic drill cores in almost, I think, 2003, in which it see that 1% decrease in oxygen isotope, same like which I previously discussed. And here this is the location where the 3 to 4 drill cores they studied, and they see this different the oxygen isotope excursion. But in the carbon 13 excursion, there is no drastically change, but due to the oxygen 18 excursion, they interpret that there is some global event is occur, and after that the cooling is started. So cooling and then warming, and then after then the cooling again is started. The magnetostratigraphic is also the dating, in which the MECO event, they are overlie, or they are present in this C19 reverse and normal polarity. Normal polarity means the normal magnetic field which you can see today, but reverse means the opposite magnetic field throughout the world. So the MECO event is also present in between the normal and reverse polarity. Source of the carbon dioxide which is caused the MECO event. So first is the volcanism, which they shows that there is two volcanism very active, Ethiopia and Mexican volcanism, and the ages is this. So they may be interpreted because of the ages is overlying in this event, so it's mean that MECO is also caused by these two volcanic activity. The another is the volcanism is linked to the erosion. So due to the, when they are eroded, so they are too much spread these lavas, which they trap the calcium and magnesium, which are captured in the soil, and though so because of they capture it, so they not go to the ocean, in which they no build the what I say the limestone. So because of limestone is not building, and the carbon dioxide still remain in the atmosphere, so due to which carbon dioxide still remain not utilized, so it causes warming. Why the carbon 13 is along the MECO is this. So some people also say that because of this volcanism activity, so the carbon dioxide value is ranges -2 to -8. So it's mean that it's very weak, because of the carbon input is sourced from the volcanic. If in PTM the carbon is biogenic methane, so it's that's why the carbon 13 value is too much negative. Metamorphic decarbonization. This is another second theory. Some people say that due to the tectonism at the Eocene time, the Alpine and Himalaya origin, due to which they subduct, and the calcium carbonate limestone of the Tethys, they react with silica magma, which they forming the calcium silicate wollastonite, and also carbon dioxide. Due to this carbon dioxide, they come from along the faults of different Himalaya origin continuously. So it shows the global warming is increasing, and due to the global warming is increasing, it's mean that long-term carbon dioxide stay in the atmosphere. So it shows that the warming is occur, and this will be the MECO cause of this metamorphic decarbonization. So here you can see the model in which they explain how the carbon dioxide stay when they are sub continental collision, and the carbon dioxide is degassing along these faults along the Himalaya orogeny. This is the new paper in which they publish in Nature Communication, in which they study the earthquake, and in this district Nepal they spread the carbon dioxide reservoir, in which you can say they go after 6 months and they still active. And this is the maps in which red area means like no carbon dioxide, but now it's very increased because of the earthquake faulting, and the carbon dioxide come from the deep water from the metamorphic decarbonization. And when they study the carbon 13 isotopes, so they see that it's range about this ratio. So it's mean that the metamorphic mental derived carbon dioxide, not biogenic. Another thing is the biostratigraphy. The biostratigraphy, when they study along the MECO event, lower bed and upper bed, so they show this planktonic foraminifera E11 to E12 zone, and Morozoella in this UK evolved to this species. The shallow benthic zone along the MECO event, they outline this 16 to 17, and the Albolina or Bolutolites, they evolved to the nummulites in Nidrina along the MECO event. And nanofossil, this is the range NP 16 to 17, and they are not evolved but changing from base to this of the nanofossils. MECO in Pakistan. The best section for the MECO is Pirkoh Drazinda formation. This is the location, you can see it. This is the overall Pakistan view, and this is the section view in which you can close up view of this picture. Lithostratigraphy of the Pirkoh Drazinda is this from starting from Cretaceous to Oligocene, and the Pirkoh Drazinda, most of the limestone, marl, and the shell, which maybe show that this will be the MECO target MECO event. So later we will be study it. Why deeper? Like some people also publish the paper of MECO from the upper Indus Basin Kohat formation. So why it is not reliable? Upper Indus Basin here and Kohat formation in the lower Indus Basin here. So they published this paper, but why I study this area, not this area? Because there is some reason. Number one, minimum diagenetic and continuously deposition. So in the shallow, high energy, maybe erosion is too much, but in outer, low energy, so maybe there is a good section, like they truly interpret the paleoclimatic analysis. Number three is the fossil and organic matter preservation. So you can see the best preservation of organic matter, you can study the paleoclimate, but here a lot of dissolution and and a lot of cementation on the shallow carbon, so maybe it's not good for the study. This is the setting, you can read it, that why we use deeper ocean for the paleoclimatic analysis. Example is also Baskel section from Turkey. They studied, and this is the paper, you can check it for this MECO event. Thank you so much for watching the video. So next we will be more go deep into this MECO event. Thank you so much for watching.